This week we started looking at systems of equations. So we started out by reviewing graphing. So here are a few examples for us to graph. Remember, we're looking at the equation y equals mx plus b. And we start with b. B is the y-intercept. That's going to be the first point that we plot. And m is the slope. Remember, we're going to use our slope, which is the rise over run, to graph other points. So for example 1, my y-intercept is -4. So in your notes, plot the -4. And my slope is 2/3. So my rise is 2, my run is 3. Since my rise is positive, I'm going to go up 2, and my run is positive, so we're going to go to the right 3. So from that y-intercept, we're going to climb up 2, right 3, plot our point. We can keep doing that, so up 2, right 3, plot our point. I've run out of room going up 2 and right 3, so remember, we can kick it in reverse. Instead of going up 2, we can go down 2, and then we would have to go left 3. So from our y-intercept down to left 3, and we can plot one more point. Notice that last point, when we put it in reverse, it still was in line with the other points. So we're going to plot another line on that same graph. This time my y-intercept is a +4, so we're going to plot that point. This time my slope is -2. Remember, that's -2 over 1. So my rise is -2, my run is 1. Since my rise is a -2, I need to go down 2. My run is a +1, so we're going to go to the right 1. So from the y-intercept, I'm going to go down 2, right 1, plot a point. I can do that again, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. When we reverse it, instead of going down 2, we're going to go up 2. Instead of going right 1, we're going to go left 1. So from the y-intercept, up 2, left 1. And there's our second line, y equals -2x plus 4. So pause the video, graph number 2 and number 3 in your notes, and when you're finished, come back and start the video again. Check your graphs here. Notice on number 2, when you were graphing B, when you plot your y-intercept of 7, you don't have enough room on the graph to go up 3 and right 2, so we can immediately reverse it and go down 3 and left 2 to finish that graph. So really, these 3 problems would create a system of equations. So a system of equations is 2 or more equations that make up one problem, right? They work together to create a problem. And the solution, remember when we were working with equations, the solution was any value that makes the equation true, or any value that satisfies the equation. So the solution for a system of equations is similar. It has to make the system true. That means it has to make all of the equations true. So that solution would have to work for all of the equations. So you can see 2 examples of a system of equations. The brace we often see just letting us know that those 2 equations together make up the problem. So a few things to write down. You can write in your notes, this is for system of equations. 2 or more equations that make up one problem. The solution works for all equations. And now this is the piece that we need to look at. How many possible solutions? If we go back to the equations that you graphed, if I'm looking for the solution for this system, I need something that works for the green line and the purple line. It has to satisfy the equation for the green line. It has to satisfy the equation for the purple line. So if we're looking for something that works for the green line and the purple line, we see this point is on both lines. So this point is the solution. So label that on your paper for me. And we can write that as an ordered pair. Now remember, when we're writing ordered pairs, it's always x, y. So here the x value of that point is 3, the y value is -2. So the solution is the point 3, -2. Likewise, if I'm looking at number 2, I'm looking for the point that works for the purple line, the point that works for the green line, and we see this point that works for both of them. So I want you to label that point as the solution. And if we look at its ordered pair, the x value is -2, the y value is 4. So the solution is the point -2, 4. And then we get to number 3. There are no points that are on the green line and on the purple line. So there is no point that works for both. There's no point of intersection. And so for this one, there is no solution. So make sure you write that on the graph. That would be the answer that I would be looking for. So to answer the question, how many possible solutions? So far, we've seen that there can be one solution. That's when the lines intersect, and the solution is the point of intersection. We've also seen that there can be no solution when there's no point of intersection or the lines are parallel. That happens when they have the same slope. If the rise and the run is the same, they're going to have the same tilt, the same slant, the same steepness, so they would never intersect when they have the same slope. There is one more possibility. All right, so a quick little check. In your head, I want you to think about how many solutions and what that solution would be. So we have this red line, and that is line y equals 3x minus 4. If I graph that second equation, 2x minus 3y equals -9, we get the blue line. So in your head, answer how many solutions, and try and find the ordered pair of that solution. So there's one solution, and that is the ordered pair 3, 5. If we were to graph the first one and the last one, y equals 3x minus 4, y equals 3x plus 2, that gives us the red and the purple lines. How many solutions? And we see that there are no solutions because the lines do not intersect. Okay, so now we're going to graph the third equation. So we have the red line, and if we graph the third equation, that gives us the green line. So what do you notice about the red and the green line? They overlap. They're on top of each other. So if we're thinking about points that work for both lines, all the points work for the green line and the red line since they're the same, since they're on top of each other. Since all of the points on the line work, and there are infinitely many points on the line, there are infinitely many points that are both on the red line and the green line, so there are infinitely many solutions. So in your notes, make sure that you have this written down. When there's no solution, when there's infinitely many solutions, when there's one solution. So there are going to be infinitely many solutions when the lines coincide. That means when they're on top of each other. It's really important that you have an understanding of this and that you have this copied down into your notes. So pause the video and get this copied into your notes, and when you're finished, you can restart the video. In addition to solving systems by graphing, like we just did, we can also solve systems of equations algebraically. And one of the methods that we can use is substitution. So for this problem, we are looking at the system y equals 12x minus 9, y equals 10x minus 49. So what I want you guys to visualize, like here in this problem, y is equal to 12x minus 9. If we thought about it in terms of the scale would be balanced because those two values are equal. We could say the same thing for y and 10x minus 49 because they're equal, scale is balanced. Since we know that y is equal to itself and the scale balances, right, instead of y, we could think about that as 12x minus 9, right? Since they're equal, they have the same value, so we could take the y out, we could replace it with the 12x minus 9, and the scale would still be balanced. Likewise, instead of y on the right side, we could take the y out, we could replace it with 10x minus 49 because those are equal values, and my scale would still be balanced.
So 12x minus 9 has to balance 10x minus 49. They have to be equal to each other. And we use that to help us solve by substitution. So another way to think about it, like here we have a y and we have a 12x minus 9. So we go to the other equation, we find our y, and then we're going to take this expression and we are going to substitute it in for y. Since it's equal to y, we can replace y with that 12x minus 9. And if we do that, instead of writing y, we're going to replace it with the 12x minus 9, and we get the equation 12x minus 9 equals 10x minus 49. We know how to solve that equation. Subtract 10x from both sides. We get 2x minus 9 equals negative 49. And if we add 9 to both sides, we get 2x equals negative 40. And if we divide both sides by 2, we get x equals negative 20. Now recall, when we were looking at our graphs, we were looking at a point of intersection, and that point we would write as the ordered pair x, y. We know x, we need to find y. We're only halfway done finding the solution. It actually doesn't matter which equation you pick. You could use y equals 12x minus 9. You could use y equals 10x minus 49. They're going to lead you to the same answer. I'm going to choose y equals 12x minus 9. And we know the value of x, so we're going to plug that in, that negative 20 in for x. So I would have 12 times negative 20 minus 9. So we have y equals negative 240 minus 9. Y is negative 249. So now we know our x, we know our y. If I were to graph these two lines, they would intersect at the point negative 20, negative 249. That is the solution to the systems of equation. So we can use systems of equations to help us solve problems. So in this case, LaTanya and George are saving up money. They're both trying to buy new bicycles. LaTanya opened a savings account with $50. She just got a job and is determined to save an additional $30 a week. George started a savings account with $75. He's able to save $25 a week. So pause the video and I want you to try and write an equation for LaTanya, an equation for George. Keep in mind, when we see something like saving $30 a week, there's a constant rate of change there. So when we're trying to write an equation, we can try and write that equation in slope-intercept form, y equals mx plus b. Remember, m is your constant rate of change, that is your slope, and b is the y-intercept. So pause the video, write an equation for LaTanya and an equation for George, and when you're finished, you can start the video up again. So hopefully you wrote y equals 30x plus 50 for LaTanya. $30 per week, that is the slope. Opening that savings account with $50, that is our y-intercept, our b value. Likewise for George, saving $25 per week, that's our slope, the value of m. Starting the savings account with $70, that is the y-intercept, or the value of b. Once we have those equations, then we can use the substitution method. So pause the video, try and work this out using the substitution method, and when you're finished, start the video again. Since we know that y is equal to 30x plus 50, we can look in the other equation and we can find the value of y, and we can replace it with 30x plus 50 since that is the same thing as y. When we do that, this y becomes 30x plus 50 equals 25x plus 75. If we subtract 25x from both sides, we get 5x plus 50 equals 75. Subtract 50 from both sides, we get 5x equals 25. Divide both sides by 5. X is 5. Remember, we're only halfway done because we need X and Y. In this case, I'm going to choose Y equals 30x plus 50. That would be 30 times 5 plus 50. 30 times 5 is 150, and 150 plus 50 is 200. So X is 5 and Y is 200. But because this is a word problem, we need to know what that solution actually means. So if we think about a graph, if we were going to graph this relationship, so if I'm thinking about X and Y, remember Y is the dependent variable on the Y-axis, X is the independent variable on the X-axis. In this case, the time would be our independent variable, and we're measuring that in weeks. And then Y would be the total amount they've saved. Then if I think about my solution, X is 5 and Y is 200, X is the time in weeks, so that would be 5 weeks. So in 5 weeks, Latanya and George both have, if we look at Y, that's the total amount saved, which is 200 here. So they both have $200 saved. This was our home learning from day 1. When you finish this video, you can come back and work these problems. So on the second day, we reviewed substitution and graphing. This would be good practice. Stop the video and try and solve these 2 problems. When you're finished, restart the video. Take a minute, check your answers, check your work. When you're finished, restart the video. We've looked at one type of substitution problem. Now we're going to look at a second type of substitution. Remember, when we think substitution, we're plugging something in, we're plugging a value in. So if we follow the same thought process as the last problem, here Y is equal to 2x plus 5. They are equal, they're interchangeable, so wherever we see a Y, we could write a 2x plus 5 instead. So I go to my other equation and I find the Y, only the Y, and I am going to replace it. I'm going to replace that Y with the value 2x plus 5. So I'm going to take the second equation and I'm going to rewrite. And when I do that, I'm going to substitute 2x plus 5 for y. So I'm going to keep the 2x minus 3. Instead of writing y, we're going to write 2x plus 5. And I'm going to keep the equals 13. We know how to solve this equation. Keep in mind, we need to distribute, but when we distribute, we're distributing the negative 3. So we get 2x minus 6x minus 15 equals 13. 2x minus 6x is negative 4x minus 15 equals negative 13. If we add 15 to both sides, we get negative 4x equals 28. And if we divide both sides by negative 4, we get x equals negative 7. Again, we're only halfway there. We need to find y. And technically, we can use either equation to find y. The top equation is the most efficient. So I'm going to use y equals 2x plus 5. So we would have y equals 2 times negative 7 plus 5. That would give us negative 14 plus 5. So y is negative 9. So my solution to this system would be the point negative 7, negative 9. Pause the video to try example 2 by yourself, and when you're finished, you can restart the video to check your work. Hopefully you got the solution 5, negative 4. If you got something different, check your work against mine and see where you made your mistake. In your next step, you can do the home learning from Monday. You can check in with someone that was here, see if you got the same answer as them, and then when you're finished, you can get started on today's practice sheets.